Hi everybody. Today we'll discuss about authentication, authorizations and encryptions. Before we talk about them, let's talk about web browser security. So web browsers they are commonly used as an internet application. We use Google, Yahoo, Chrome, Firefox or Apple Safari. They all are the browsers. So web browser allows an information resource such as a web page, image, video, or even virtually any other type of content to be displayed on a computer from a remote server. Many applications used today use web browsers as their interface, so they can provide consistent and familiar user interface. So since everyone is a potential user of a web browser, so it's highly important that everyone learns about the risk associated with browsing unknown content on the web page. So authentication, authorization and encryption, they are used in everyday life. One example can be like we all use booking and taking in airplane flights. So encryption is used when a person buys their ticket online at one of the many sites that advertise cheap tickets, for example. Upon finding the perfect flight at an ideal price, a person goes to buy the ticket. This is where we use encryption, because used to protect a person's credit card and personal information when it's sent over the internet to the airline. And the company encrypts the customer data so that it will be safer from interception in transit. Talking about authentication, it is used when a traveler shows his or her ticket and driver license at the airport, so he or she can check their bags and receive a boarding pass. Airports need to authenticate that the person is who he or she is, and they purchase the ticket before giving them a boarding pass. And the authorization, it is used when a person shows his or her boarding pass to the flight attendant, so he or she can board the specific plane he or she is supposed to be flying on. So a flight attendant must authorize a person, so the person can then see the inside of a plane and use the resources the plane has to fly from one place to the next. Some more example about where encryption, authentication, and authorization are used by computers. So encryption should be used whenever people are giving out personal information to register for something or buy a product. Doing so ensures the person's privacy during the communication. Encryption is also often used when the data returned by the server to the client should be protected, such as a financial statement or even test results in hospitals. And the authentication should be used whenever you want to know exactly who is using or viewing your site. Okay. Other commercial websites such as Amazon.com require people to log in before buying products, so they know exactly who their purchasers are. And the authorization should be used whenever you want to control viewer access of certain pages. For example, Lone Star College students, they are not authorized to view certain web pages dedicated to professors and administration. So the authorization requirement for a site are typically defined in websites. So authentication and authorization are often used together. For example, the students at Lone Star College, they are required to authenticate before accessing the student link. And the authentication they provide determines what data they are authorized to see. The authorization step prevents students from seeing data of another student. Okay. Talking about the password. In early days of computers and mainframes, password is stored in a database as a plain text. So they were converted into hash function. So when you wanted to sign in, let's say a gatekeeper application would ask you for your password. It would take whatever you typed in and check if it was equal to the whatever it has stored in the database, and if true, you were granted the access. As the internet evolved and grew, malicious hackers started gaining unauthorized access to systems. Once they were in, they would immediately download the plain text password database and have instant access to all user passwords. So the developers and system administrators needed to come up with a solution to this problem, and the solution they came up with was password hashing. So think of a hashing algorithm as a machine. In one end you input any text or binary data. Out the other end you get a number that is a certain length, let's say 32 digits long in our example. So the data you feed in can be any size from a few bytes to many terabytes or even larger. No matter what data you feed in, you get a 32-digit number that uniquely represent the data. Okay, so hashing algorithms differ in the way they work. The most notable differences or the length of number each one basically uses. MD5, which is extremely popular, uses 128 binary digits, and then secure hash algorithm uses 256 bits like binary digits. So technically what happens when a system administrator or developers, they first encounter the security problem with password database that was stored as a plain text. So what they did, they turned to hashing algorithm for help. Okay, so they would just store a hash of your password. The number that is hashing algorithm generates when it operates on your password. When a user changes their password or when a user account is created, the new password is typed in for the first time. The computer security application takes that password and runs it through a hashing algorithm and stores the resulting number in the database. So the next time when you try to sign in and enter your password, the security system runs the password you entered through the same hashing algorithm and checks if the resulting hash matches the hash in the database. Okay, we have covered one example on the hash algorithm and the password, how they are generated into hash in our other next video. I hope you watched it. If you have not, please make sure you watch it. It will give you a better idea. So speaking more about these passwords, then there was a table with the commonly used by hackers to crack password database that use ordinary hashing without any additional security. That's called rainbow tables. So rainbow table attacks on hashed password database are very effective because they are fast. Okay, to help protect against these kind of attacks, developers and system administrators, they came up with a technique which was called salting passwords. So how salts work? A rainbow table attack relies on a hacker being able to take a dictionary and pre-computed hashes of the words in that dictionary and compare those hashes to the hashes in a password database. To defeat rainbow tables, the information security community invented a salted hashes. Okay, so the concept is relatively simple. So when you create a new password, instead of just running the password on its own through the hashing algorithm, basically you generate a random little piece of text, put that text at the beginning of password, then run the combination of little piece of text and the password through a hashing algorithm. Then you store the little piece of text as like a plain text and the resulting hash, and that little piece of text is called a salt. This is the example of the password hash salting image. Have a look, and then if you have a question, we can discuss in the classroom or feel free to send me an email. So when someone wants to sign in, they type their password. The security application takes the stored piece of text or salt put it at the front of password that was entered and they run it through the same hashing algorithm to get the hash. Okay, it's important to note that the salt or the little piece of text is stored as a plain text with the hash. It's also important to note that the salt is random for each password. In other words, every password has its own special little piece of text.